this working? Yeah, hopefully. Awesome. Right, so I'm going to talk a little bit about buzzwords, and mainly that's because I've been talking about NSClient, which has been like the Windows thing throughout the ages, and that's kind of boring. And then you have all the hipsters who's doing like Docker and Kubernetes, and you go like, I want to be one of those. But my name is Michael Medin, and I've been doing NSClient for way longer than I would love to. I usually title myself as some sort of architect this or architect that or architect whatever. But I'm a developer and I love to build things. And there's something magical going from nothing to something. The feeling of just sitting there with a grand idea, and then somehow later on you have built something that actually you can touch and feel. Right? But somewhere along this journey of building, everything from plastic pieces to wooden pieces to electronics and whatnot, you realize that it's not building you love so much as the fact that you have a grand idea and then you have built something. But in between the grand idea and the having built something, there's a lot of grunt work that is actually boring, right? I realized this when I was little because I went skiing for the first time in my life in Norway, where they have like, snow, really snow, not like in Sweden. You go there and you sit in the cabin and you look out and say, wow, I'm going to build the greatest snow castle in the world, right? And you run out and you realize that you just fall down into the snow. And then it goes to here. And the snow is not wet, so you can't build anything with it, right? It's just cold, and it's inside your shirt and inside your shoes, and you're miserable. And I've never skied since, by the way, so yeah, traumatic experience. So, when I'm sitting there on the porch and I say, like, it would be awesome to, build this and do that, and then I realize that it's going to be a lot of work, right? So the natural progression is, of course, to get someone else to do that work for you, right? So I got myself a couple of kids and figured, they're going to do everything. I'll just do the planning, and then I'll sit on the porch and enjoy the results. Fortunately, that didn't really pan out, because thus far they have committed 0 lines of code to NSClient. They don't even have GitHub accounts. I have failed as a parent. I have bought every single STEM toy there is, right? I have robots, I have electronic kits, I have everything, and they like nothing. So something has failed there, right? But then, a couple of weeks ago, I was sitting there building some Halloween decorations, of course, electronic lights and that kind of stuff, Raspberry Pi. And my daughter comes in and she's like, oh, what are you doing? And starts tinkering with it. And I go like, wow, finally, after 9 years. And then you realize that now is this really precious moment where either I start, to push her, and she'll think it's boring and dad stuff, and she won't do it anymore, or I'll do nothing, and hopefully she'll forget about it. So I don't really know what to do. But you're thinking, why is he talking about this, right? Because we're supposed to talk about NSClient, or more importantly, we're supposed to talk about buzzwords. But I'm not going to do that. Instead, I'm going to talk about what NSClient is. And NSClient is a general purpose agent. What that means is that it supports various protocols, it supports checks, it supports metrics, it supports events, and it supports scripts. And these are kind of Lego pieces which you can put together and build some sort of monitoring solution on top of this. I usually say that it's modular by design and highly extensible. Other people tend to say that it's very complicated. And there is some truth to both of these sides. And I've sort of gradually tried to make things simpler and sort of say this is the way it should be done, instead of saying, here are a bunch of Legos to build something cool. 052, which was out a couple of years ago, had a RESTful API, documentation improvements, zip modules, OP5 client if you're using OP5. But fairly boring stuff. Nothing buzzwordy, right? Nothing cool, hipster. Then 053 was out, and that's one of those unreleased versions. You can download it and you can use it. It works fine, but the web interface is kind of broken. Because I thought Angular 2 was going to be the future, and I spent months trying to build a web interface in Angular 2, and then I built something in Express, and it took a weekend. So that's how wonderful Angular 2 is. That introduced an Elastic client, a single client, remote modules, documentation. Again, boring stuff, right? But then we have 060, which is really the next version that's going to come out as a beta version in like 1 or 2 weeks, and hopefully released before the end of the year. And I honestly think that's going to happen, but we'll see what happens. I've spent a lot of time updating all of the dependencies and internal libraries and all that kind of stuff, which is, again, rather boring. But what is less boring and slightly more interesting is open metric supports. And that's essentially the Prometheus metric stuff, which you can start scraping through NSClient. As well as Docker support, which means that you can start monitoring containers and things like that. AWS didn't really pan out, unfortunately. It's going to happen in the next version, but I figured it's better to release this as is and then come with a later version because I haven't had time to do that. There's also a new web interface that's actually working. That said, general purpose agent, right? So we said we supported protocols. And what do we actually mean by that? With protocols, we have different ways of talking to the outside world. We can talk to Elastic, we can talk to Graphite, we can talk to Isinga, to Nagios, we can talk via NRPE. There's a whole bunch of these protocols that we support. And depending on how your monitoring situation looks, you will need different protocols. But they all kind of work the same, they all kind of do the same, it's just a different way of communicating, right? So the end result will be something along the lines of you loading the module that provides the protocol, and then you specify, where you're going to send the data or from whom you're going to receive requests from. Then we support checks, and when we say check, what we mean is, some sort of code that's running to decide whether something is good or bad. It's a biased value, you might say. So essentially, we're using this for alerting when something goes down, or when something is broken, or when something is wrong. But we can also use this for automated recovery. So if a service is stopped, we can start it again. If the disk is full, we can delete some random files, or something along those lines, right? The way this usually looks is that you enable a module that provides the various checks command you need, and then you can use those check commands to check something. Then we have something slightly more modern, if you will, metrics. This was introduced in the 70s or 80s or something along those lines, but it's become really hipster again. The difference between a metric and a check is essentially that it's unbiased. We say the value is 45, and then someone else will have to decide whether that is good or that is bad. The way that works is usually you load the module that provide the metrics, and the metrics are just there, and then you can ship them off to Elastic, or you can ship them to Graphite, or you can do some processing with them to figure out where you want to go from there. We can also take this performance data from various check commands that we install or download. And the way to do that is slightly more involved, because then we need to have someone who runs that check command, and every 5 minutes or 5 seconds or whatever, and then we can take the metric part of that check command and send that to somewhere, for instance, Graphite or Elastic. Then we have events, and that's essentially when something happens, like civilization ending or a process is stopped or something along those lines, right? And this is a good way to enforce state, because if a process is stopped that shouldn't be, we can again start it. But this is more coarse-grained than, for instance, a check command or something like that. So we can do a lot more things with it. This usually looks a bit like this. We enable the module that supports, the thing we want to monitor, and then we create some sort of filter saying that, hey, Notepad is started, let's do something. We can send that to a notification somewhere, or we can, inject logic that will do something like start something, stop something, or change something, right? We also support logs, but it's important to understand that we don't actually support logging, as in shipping logs back and forth. So this is not a replacement for, Splunk or Elastic logging or something like that. But what we can do is we can read logs, and we can interpret logs, and we can find things in logs. The way this usually works is that you enable the log, and then you run the command with many parameters, because you need to specify the format, the file, how we're going to parse it, what we're looking for. This is also highly inefficient, because every time we run this command, we usually have to start at the top of the log and go all the way down, right? A much more efficient way is to listen for events, which means that we are looking at a stream of events, and we are processing them one by one. This has less overhead, and they will just be processing the new events that's written. We can do this for logs or for event logs or things like that, right? Then we have scripts for essentially everything else. And this is kind of where NSClient shines, because with these scripts we can do anything really. We can write our own protocols, we can write our own check commands, we can process metrics, and we can change and combine things. So this is very good for adding custom behavior, but it's also very good for modifying behavior. If you don't like how something works, we can change that. The way this usually looks is that we enable the module that provides the scripting support, and then we load our scripts, and that's pretty much it. Obviously, we need to write them as well, right? And these are sort of the tools that are in the toolbox. To actually start using them, the first thing we need to figure out is which protocol are we going to use. Because if you're using a Singa or some other monitoring tool, you have a whole flora of protocols that you can use to talk to NSClient. I personally tend to sort of favor REST-based communication because it's easy to firewall and it's easy to manage. And then you can use check NSCP web, which will invoke the REST API. But I think most people probably use NRPE or NRDP, depending on where they're coming from. And of course, Graphite is my go-to system for metrics, but you can also go Elastic and other solutions as well. The other thing you need to figure out is which check paradigm you have, because again, given the Nagios inheritance, there is different ways to do monitoring. We can either do it actively, which means that the central server goes out every 5 minutes and say, hey, are you doing fine? Hey, are you doing fine? Still fine? And it does that every 5 minutes. But then we have the other so-called paradigm, which is passive monitoring. And essentially what we're saying here is the opposite, so that the server is going, the monitored host is going to the server saying, I'm still feeling fine, don't worry. It's always been kind of weird to me why we have this, because essentially it's a firewall paradigm, right? Why do I have to change the tool set because my firewall goes in a different way, or my network is set up differently, or something along those lines? It's weird. But, Nagios is an old product, and, all of the product is sort of built on top of Nagios, has inherited a lot of the good and bad things from Nagios, right? So maybe this is just something that comes from that sort of ballpark. But then we have the whole metrics world, right? And again, we have different paradigms, because in the metrics world, we can either pull our metrics, which means that, Prometheus or whatever goes out to all your hosts and fetches these metrics every 5 seconds or 30 seconds or whatever you like. But we can also push metrics, which is obviously the opposite, right? So all your monitor hosts will take their metrics, push them to a central repository somewhere. And then you go like, really? We didn't change anything? We just changed the format? We still have different solutions? And what's even worse in this case is that there's a lot of proprietary solution, which means that it's not just changing the protocol, we also need to change the entire tool stack when we need to change our firewall paradigms. I mean, if you're using Prometheus and you want to change from push or to a pull-based model, it's going to be a lot more work. So hopefully at some point someone will come up with a standard that can do both of these without having to change everything, right? So that we can just have a monitoring protocol that supports all of this. Now you're probably sitting there angrily saying, hey, buzzwords, right? Kubernetes, Docker, where is it? I want it. And you're not going to get it, sorry. This is something I have been pondering for the last year. Should you do checks or metrics? Because I come from a Nagios background, so for me, checks has always been the go-to thing. And nowadays, a lot of the hipster guys are doing metrics. And, should you just abandon checks and go with metrics or not? And I think last year, when I talked about this, I said that you need both at some point. You need graphs to look at things, but you also need alerting. But you also needed other things as well, because you need logs to be able to get visibility into your system, and you need to capture events to be able to overlay them on your graphs, right? So to have some sort of observability set up, you need to have all of these. You can't just have one or two or anything like that. Now, for the astute reader, you probably noticed that if we have a check, we can turn that into a metric by using the performance data. So arguably, as long as you have a check-based solution, you can just take all the performance data, send that to a data warehouse somewhere, and then you have a metric solution, right? We showcased this a couple of slides ago. And for all of the Prometheus people in the audience, that's what Prometheus does, right? It takes a metric and it turns it into an alert, or a check, if you will, telling you whether this value is good or bad. So it could be argued that if we have one of these, we can sort of transform it into the other. And again, then the question becomes kind of valid, should you just have metrics or should you have checks, right? Should we abandon the whole concept of checks and just start going with, the metrics way? Because that's what a lot of the, the big companies like Uber and Google and those are doing, right? And I've sort of been pondering this. I worked for a large, I don't do startup anymore, but a large fintech company in Sweden. and they were going, all metrics, and we had a lot of issues there. And currently I'm working for a really small company, and you go like, so should we go metrics or should we go checks? And this is something which I've sort of looked at from different dimensions and different directions. And what I'm going to try to I'm not going to answer which one is better, but I'm going to try to shed some light on the differences between them. And just sort of to clarify, when I say check, what I mean is that we're running some code on the nodes that we are monitoring to figure out whether something is good or bad. And when I talk about a metric, we're essentially just fetching values, and we are processing all of those centrally in our monitoring solution. And we're going to look at this first from a technological perspective. If we look at checks from a purely technological perspective, it gives us a lot control because we're executing code. It means that we can do things, right? We can say first we do this, then we do this, and then we evaluate something, right? It's also easier to reason about this because it's a number that's going to a specific host. So if we're looking at that machine, we can see how that number affects things by looking at logs or stats or something like that, right? So it's easier to reason about it when you're going with checks. It's also a lot more extensible. If the value doesn't exist, you can add that value by doing some sort of logic or by executing code, right? Now, on the other hand, the problem with checks is that they tend to be rather simple and stupid. I mean, if you look at most of the check-based monitoring solutions, 90% of it will be check CPU, or check memory, or check disk. It's not very helpful, right? And you end up with having 25 different checks for checking your SQL server or something like that, which is not very helpful either. And it's quite hard to manage because you need to write all of these scripts, you need to transport all of these scripts, and you need to maintain them, right? And it requires a lot of upfront configuration. You need to figure out what do I actually need to monitor here. Which scripts do I have? You need to research them, figure out. Now, if we look at metrics instead, we have this magical time dimension, right? I mean, we can see how things change throughout history. And that is really, really powerful, and it is really, really magical because it means that if I'm tuning and tweaking my monitoring, I can see how that would have happened previously, right? If I change a threshold, I can look at the data I had for the previous week or the previous month, and I can replay that stream of events, and I can see how that would have impacted the decisions the monitoring system would have taken. It's easier for me to actually see what my changes will do without having to wait for the next thing to break, right? Or having to fake something breaking. And you can also take all of these numbers and just shoehorn them into some awesome machine learning algorithm and upsparms, millions of false positives. And that's just awesome because then you'll be woken up for no apparent reason whatsoever. Now, the drawback to metrics is actually dimensions. Because it's really difficult to see something when you have this huge sea of data. I mean, if you have accidentally grouped 10 servers together, you can't really tell that from a graph, right? Because the graph is just showcasing all the numbers. If you have 2 servers, 5 servers, or 10 servers, you're not going to see that. So unless you have a very good dimensional strategy, it's very easy to get lost and get the wrong metrics. It's also that you get a lot of metrics just out of the box, which means that you have 10, 20 different metrics for response time. And it can be kind of difficult to understand what the difference is between these metrics. And I mean, one thing that really we had an issue with was that we had like an admin interface where we do keep lives, and then we had a service interface. And we accidentally took the response time from both of these because we didn't differentiate between the 2 interfaces in our dimensions, which meant that we didn't really detect that we had bad response times on the service interface because the average values coming from the admin interface and the load balancer polling every 10 seconds sort of made everything look good, right? It's also difficult to reason about this because it's all functional. So you take all of these values and then you transform them into other values and into other values, and you add all of these functions on top of it, and out comes something that looks really nice, but you don't really know what it is, right? And unfortunately, a lot of these tools we have on top of this, they don't really help you with this. They just say, yeah, let's do a derivative here, let's add something, and then we do a, integration or something. And from a mathematical perspective, this has absolutely no meaning whatsoever. Something that's quite common is people who are doing averages of averages of averages, which mathematically means absolutely nothing. And it's very easy to get lost in all of these functions that you need to add because there is no one who's dictating how this actually works from a mathematical perspective. And math is really, really hard. It's difficult to get this right. So I think if we look at this from a technological perspective, I'm not so sure that metrics is actually a benefit. I mean, the time thing is quite magical, but the drawback is that the tools we have currently are very limiting. They don't really help you to understand the data. They give you really nice graphs that look good, but they don't really ensure that those graphs reflect the truth. And they don't really ensure that the thing you're looking at is actually the thing you want to look at. And I mean, how many people have testing for their graphs? It can't be done, right? So you're just hoping that it's working. But that said, the time dimension is interesting, and that gives us a lot of power. So if you look at this, for legacy versus greenfield, right? I mean, if you have an old legacy infrastructure that is already running your monitoring, it's established, you know what you're doing, you can always add metrics on the side and do pretty graphs, right? That's going to be easy. If you're going to change all of this over to a metrics-based solution, it's going to be really expensive. It might be better, we don't know, but you're going to have to relearn everything, right? So for a legacy case, it's probably not going to be beneficial to move to metrics. But what if you have this? You're going to build a brand new Ferrari. You get to pick your frameworks, you get to pick your infrastructure, libraries, everything, right? You can do whatever you want. Now, if you do this with checks, it's easy to prototype these because you can say that we're going to run this and this and this check on this system to make sure that it's running. It's going to be a much better learning curve because you don't need to figure out what all of these metrics do. I mean, the way at least I usually approach this in a metrics-based solution is that I sit for 3 weeks and I look at the graphs and I try to figure out which ones are actually useful to me, right? And it's difficult to do that up front. You usually end up doing that down the line when something is broken and you said, oh, so this was the graph I should have been looking at. And then the next week something else breaks and then you look, oh, so this one was this week I should have been looking at, right? And with checks, we can still graph performance data. So we can still have all of these metrics, but if we do the bias thing with something we understand, it's going to be easier. Now, if we do this with metrics instead, we probably will get a huge uptake in developer involvement. And that is a key factor. Because if the developers are helping you to build your monitoring, it's going to be way better than you building your monitoring on top of whatever they have developed. But this sort of assumes that your developers are friendly and will help you with this, and that's not always the case, right? So in a situation where the developers have the potential that they're going to run this system, this is going to fly really well. But in a situation where they think that, yeah, those guys are going to run it, I don't really care, it might not fly quite so well. What we will get, though, is a much more modern architecture. I mean, the metrics-based tools, they're built to scale. Most of the check-based tools are, quite frankly, not built to scale, and they're difficult to scale. That said, Prometheus enterprise scale is not easy either because of security issues and things like that, and scaling huge data sets is not easy as well. But what they do have is there's a lot of good use cases, and what I mean by that is, if you have a service, people at Google and Uber and things like that, they've written long articles about how they do monitoring, which metrics do they look for, how do they interpret these metrics. And that is really, really powerful because it means that you can know how to do this, maybe not the right way, but at least the right way according to someone else. If you look at the check-based monitoring, a best case scenario is someone who wrote a PDF about monitoring, SQL Server 15 years ago. That's not going to be very helpful, right? So I think if we look at this from a legacy perspective, it's probably not going to be beneficial to move to checks. And, in this Greenfield scenario, yeah, maybe, but I'm not convinced that it's a clear case. I'm not saying that, metrics is worse. I'm not saying checks is worse. It depends, So lastly, we're going to look at this from a historical perspective. And, the whole monitoring thing really started off with SNMP back in the 80s. And you had all of these dots and numbers. And I mean, this is still the thing today, 20, 30 years later. So this was not bad, right? But the reason why this worked was because it was standard hardware. You had 25 different routers, and that was it, right? If you had a Cisco router and you swapped it out for some other router, your monitoring stayed the same because they adhered to the same standard. But the scope was very limited, right? We only had, a number of devices that we could monitor. And the reason why we had the dots was because of low bandwidth restrictions, right? But we could always explain the dots with, various tables. And along comes Nagios, right, the open source world, and all of a sudden we have to monitor everything, right? It wasn't 25 boxes anymore. It was hundreds of different software that people, built in their basement that didn't have any monitoring whatsoever. So the only way we could monitor these black boxes was by writing scripts that looked at various aspects of them, right? And everything had to be free, as in beer. You sat at these sales meeting, and people were like, what, we're going to pay for monitoring? No. Let's go with something that's free. And then we spent, hundreds of hours configuring it, which costs way more than having bought something, but that's another story. And this was kind of, why Nagios looks the way it looks, right? And in comes the Prometheus generation, and I know that there's Sensu and a whole bunch of other tools that kind of do the same thing. And these are sort of built on top of custom-built solutions, right? I mean, we have developers who are building a solution which should be monitored. They are adding the metrics that they need to monitor their own solutions, right? It's extremely flexible because you can do whatever you want. And if you're going to monitor something you're building, you're going to be very prone to sort of expose the right metrics. And it had to scale linearly, which means that it should be really cheap when you start out, and it could become really expensive down the line, because once you are down the line, you either have a shitload of seed money, and then money is no effort, or you have a lot of user, and then money is no problem either. But it has to be cheap when you start out, right? And this, I think, is really why we have a lot of traction in the metrics-based world, because if you build it and you run it, metrics makes a lot of sense, because you can build in the metrics that you need to monitor the system. On the other hand, I usually end up in this scenario, and then it's not clear case anymore, because the developers is not going to expose the metrics I need. They're going to, shoehorn in some metrics library that just spews out millions of metrics that has no meaning whatsoever, and they're going to say monitoring done and move on. And somehow I need to interpret these, and I need to figure out how I'm actually going to work with all these metrics, or whatever we have. And in this scenario, a check-based solution is going to allow you to actually take these values and make sense of them in a much more structured fashion than you will from a metrics-based solution. So I think at some point, when in the Nagios day, when we have to choose between passive or active monitoring, we usually ended up having to use both, right? And when we come to metrics, we needed push and pull, because we had different firewall paradigms, we had different ways of doing this monitoring. And maybe it's the same, maybe it's metrics and checks. Maybe the monitoring toolbox should be Icinga and Prometheus, not Icinga or Prometheus. And maybe we need to sort of realize that this is just the way things are now, that we need a lot of tools in the toolbox, and we need to use all of them. But what we do need to do is make smart checks, because regardless of if you are monitoring with metrics in Prometheus, or if you are monitoring with checks in Icinga, 80% CPU is not going to be helpful to you. And the sad thing is, when I was working at this large fintech thing with, several hundred different teams doing, you build it, you run it, 90% of them was doing this. And I said, what, you don't have autoscale? Yeah. So when is this going to be triggered? I don't know, but, it's good to have monitoring. Yeah, really good. And, the Java application that you monitor memory on, it's a bit like the memory line is completely flat, because you configure Java how much memory it should have. Yeah, it could be a bug in Java that it sometimes takes more memory, but probably not something you need to monitor for. And same thing with disk space, right? I mean, all of these are just stupid to monitor. They will not give you any help. That said, I would like to say that for the last 2 months, I've had a lot of problems with disks running out, even though we have autoscale. But apparently, we haven't really configured the Docker thing correctly, or so they tell me. Anyway, we need to do smart checks, We need to do smart monitoring, and we need to take this, where we have a turnkey solution that doesn't just work for monitoring our services. We need to be able to monitor our databases, our storage, our network, and all of these infrastructure with the same ease and with the same best practices and with the same standard as we have for a lot of the services that we monitor today. And I know that you're all sitting there, buzzwords, right? Where is Kubernetes? Where is it? I want to have it, right? And we're not going to get it. Sorry. So in NSClient, we have scripts, that can actually do magical stuff, right? We can write them in Lua and Python and soon in Rest, hopefully. But it's been saying that for quite a while now. And sort of the concept here, this is a Python script. We import some functions, and then we have an init and a shutdown function. Init function runs when NSClient starts. Shutdown function runs when NSClient stops. So in between, you can do whatever you want, right? So this is a simple hello world. And of course, we can provide checks in these scripts if we want to have someone running checks on them. The way we do that is by writing a function that implements the check, and then we bind that to a command. We can, of course, do metrics as well, because we are fancy and modern, right? And the way that works is, again, we have a function that consumes the metrics, we have a function that provides the metrics, and we bind those. And the cool thing here is that we can both read other metrics, and we can produce our own metrics. So we have the ability to take some metrics, do some math on that, and hand it on to, to another metric somewhere. And the interesting bit here is that we will be doing this on the machine. So we don't need to care about dimensions, we don't need to care about all of these difficult stuff, because we are taking a value and transforming that into another value. And then later down the stream, we can do some fancy stuff across the whole set of data. But that makes it easier to actually manage metrics than it would have been if we are doing all of this centrally. Of course, events, if the world were to end, we can take care of that as well. In this case, we say that if you have an event coming from check system, send that to my script, and then I can do something. So for instance, if someone is starting a process, or if someone is stopping a process, we can do something, figure out why it was started, why it was stopped, and then we can either kill it or start it, or take some action or do something useful. We can get a glimpse of this magical time dimension because we have a stateful script, right? So we can look at the past values, we can look at, well, not future values, but we can somehow impact future values by looking at the values we have currently. And of course, because we have, configuration, we can do that as well. And then the interesting bit here is that if we do this through a standard interface, it means that we can configure them through the registry if we're on Windows, or a file, or a remote storage, or we can use the REST API to update this. So we get all of these superpowers just because we have scripts that are running in a framework that provides us with things we can do. And of course, we get the web interface for doing our configuration as well. And then we talked about this briefly before. We can talk between our check commands. So if you don't like the way a command is working, or you want to change some tiny aspect of that command, we can run that command, and then we can modify it either on the request pipeline or on the response pipeline. And this gives us the ability to fix something that's slightly broken or change something that's not suited to our environment. Then we can package these into zip modules, which is essentially a way of take all your scripts, put them in a neat little bundle, and say, hey, there is the one artifact that we are distributing. So we have a manifest that describes what this zip file contains, and then we can just enable everything with one line. And of course, infrastructure as code is really the thing nowadays. But instead of having to generate all of these templates and all of this configuration and all of this stuff, we can do better. We can auto-detect. If someone starts SQL Server, we probably want to have SQL Server monitored. If someone starts Nginx, we probably want to have that monitored, right? So somehow we can figure out what's running on this system, and then we can take actions and enable the monitoring that is required by this system. So we don't need to generate any configuration at all. And we can package this in our neat little bundle, and if something doesn't really work for this server, we can customize it on a per server basis, instead of having to do that centrally. And I know I'm stalling, right? Because we want to have some Kubernetes stuff and some Docker things and all that kind of nifty, cool stuff. And we're actually getting that, as I said before, in the 06 version. That'll be out in a week or two. Plan was to have it out now, but unfortunately Halloween came in between. So what we will get then is, the ability to check if a container is running, and you go like, oh really? That's it? I mean, all of this time, and that's it? And then we'll get some other things as well, because we'll be able to take the metrics from our Docker containers and use them in our scripts, or we can ship them off to our metric store, or we can actually do them to do checks and things like that on it. And we will have events, so whenever a Docker container is started, we will be notified. We can take action if someone is starting a Docker container that has a certain name or has a certain base image or has a certain tag or something along those lines. And this gives us a lot of interesting superpowers, because this means that if we have a service contract where we say that, our containers have an environment variable that says this is the check command to check, or these are the check commands to check, what we can do is actually, whenever that container is started, we can, or whenever a container is started, we can see, has it set the environment variable? Has it set the tag? We can take that tag and say, okay, so these are the check commands you want me to run inside your container. So I can run those for you, and the only thing you need to do is deploy NSClient somewhere in your Docker infrastructure, and it will just pick up all the other containers automatically. And with some scripting, we can then make sure that it runs all of your check commands, which are provided by, for instance, your developers inside their containers to, figure out what they want to do. We can generate metrics, and we can do all of these magical stuff, right? And then we have the check open metrics module, which allows us to scrape stats endpoints and metrics endpoints and things like that. And that in itself is, yeah, maybe. But again, if we take this together with the fact that whenever a Docker container is started, we can see, do we have a stats endpoint defined as an environment variable or a tag or something along those lines, then we can automatically start scraping that, which again means that we can deploy NSClient in our cluster, and it will just magically pick up all the containers and start monitoring them without you having to configure anything. You don't need to have sidecars, you don't need to have all that kind of stuff. It just magically picks up everything and starts monitoring it. But the interesting bit here is that this is all through scripting. It's not all through configuration or all through some tool that someone built. So we can adapt this, and we can change it, and we can do a lot of the stuff that we need to get this running. And if we're looking forward, in the next version, we will have a Kubernetes support, Hyper-V support, and AWS support as well, which means that if you're running a large AWS cluster or an ECS cluster, you can just drop in NSClient into that ECS cluster. It will pick up all your containers and start monitoring them automatically, which I think is quite neat, hopefully. We'll see how this sort of turns out. This is, as I said, things that are coming. The Docker stuff and the Open Metrics stuff is finished. So I just essentially need to package that, get it out. AWS stuff is kind of finished, but not really. But all of this is coming quite soon. And I think with this, we can do both metrics and checks. And when it makes sense, we can use metrics. And when it makes sense, we can use scripts and checks, both to generate metrics for the ones we need and to change and mutate metrics, but also to do classical checks to figure stuff out and find information from our containers. And we can do this in the cloud, we can do this in our Kubernetes clusters, and we can do this pretty much everywhere automatically without having a lot of configuration. We can be adaptive, right? So with that, I want to say thank you for listening. And there were a few buzzwords at the end.